Hi everybody, so today we're looking at some stoichiometry, and this is specifically going to be for things that could be in excess or the limiting reagent. So let's have a read there. A mixture of potassium nitrate and sulfur react according to the following equation. One of these is in excess, which reactant is in excess. Now, don't fall for the trap that just because sulfur there has more grams that it is going to be in excess. Okay, that's not what determines this. Okay, so how we determine there now is we go to part I there is in terms of number of moles. So you're actually going to carry it out like you're doing an empirical formula. Okay, so let's write out our your KNO3, and we're going to get the number of moles of that. Okay, so number of moles equals mass of MR, so that's what's that? That is 20.2 grams. 20.2 grams, and we're dividing that by the MR is 101, if you get that out correctly. So that will give you 0.2 moles. KNO3, okay? Put a little box around that. Okay, part 3, or next one, so, is sulfur. Same principle again, guys, okay? Get the number of moles. So number of moles equals, and sulfur was 24 grams, and if you get the MR sulfur, it is 32. 24 divided by 32 gives you 0.75 moles of sulfur. Whichever has the higher number of moles, that is the one that's in excess. Okay, so actually in this case here, sulfur is in excess. Okay, it had a greater number of grams, had a higher mass, and it's also in excess in terms of the moles. Okay, but I can't stress this enough. Okay, it is the number of moles that determines if a reactant is in excess. Okay, not the mass. So sulfur is in excess. Now the second part of the question is asking you to figure out what mass of this reactant is unused at the very end of it. Okay, now you have to be careful there because it's asking you not for the mass of the reactant, because we obviously already know that, but unused. So when they reacted the sulfur, 24 grams of sulfur, with the potassium, 20.2 grams of potassium nitrate, how much sulfur was unused? Okay, because we already know it's in excess. Okay, so what do we do? Well, it's not that difficult. Okay, all you have to do there is you have to find out the number of moles that will actually react fully, completely with the KNO3. Okay, so what do we do? You want to get your 0.2 moles of your KNO3, 0.2. You're going to multiply that by 5. Sorry, you're going to divide that by 4 and multiply it by 5. Okay, where am I getting the 4 and 5 from? So 0.2 moles of your KNO3, which is over here. So I divided that by 4, because there was 4 in front of it, and I multiplied it by 5, because there was 5 in front of the sulfur. Okay, and when I multiplied those two together, I got an answer of 0.25, and that's 0.25 moles of sulfur, okay, required to react with the 0.2 moles of KNO3. Okay, so if we use 0.75 in total, 0.75 minus 0.25, if we do that out, we're going to get 0.5 moles sulfur unused. So it's going to be, this is the mass that we're going to use now. This is the number of moles that we're going to use to figure out the answer. So we plug it into our formula. Okay, mass equals number of moles times the MR, and we put in our values. So it's going to be 0.5 times the MR, and the MR of sulfur is 32. And when you multiply that together, you're going to get 16 grams of sulfur unused. Okay, I'm going to highlight my answer there. So that was the hard part, really. in this equation here was just to realize how much of it was unused. Okay, so all I did there was I went up to my KNO3, I divided that by 4, and I multiplied it by 5. That was it. You could have, if you wanted to, have done it the other way around. You could have got up to the sulfur, and that's my 0.75, divided that by 5, and multiplied it by 4. It would have been the same thing. Okay, the same way. Now, we have part I complete now. Let's look at part 2. Calculate the total volume there of measured in STP. Well, as soon as I see volume and STP, there is only one formula I'm going to use. So volume equals your number of moles times Avogadro's number. Okay, now we know Avogadro's number automatically is going to be 6 times 10 to the power 23. That's grand. Okay, now we have to figure out what our oh, I'm making a mistake here, haven't I? I'm thinking of number of atoms, not the STP. Okay, apologies for that. It's number of moles times STP. Okay, so we know our STP, okay, is 22.4 liters. So we have to figure out what the volume is now. Okay, that was my fault there, guys. Okay, so we have to figure out how many moles of the gaseous products that we're dealing with here. Okay, so that's all of it. Okay, so let's have a look here. What are actually gaseous? So we have a G there, so our N2 is a gas, and our SO2 there is also a gas. Okay, so we actually have a few things there in terms of the gaseous products. So this is tricky enough. Okay, so we're going to apply the same formula again. Okay, as what we've been doing before. Okay, we have the number of moles of one of these over here. We'll look at KNO3. So 0.2 relates to 4. I'm just going to do a little aside over here. So 0.2 relates to 4. So therefore, if we want to find out what 1 is, okay, I'm going to do 0.2 divided by 4. Okay, so this is 4 is to 1. So therefore, my my 1 is going to be 0.05. Okay. Now let's go back over here. We have two N2s. Okay, so I'm going to get my 0. I'll do it over here. So this is N2. So it's two N2s. So it's going to be 0.05 multiplied by 2. And if you do that out, you only get 0.1. Next, we're dealing with 5 SO2s. Okay, so we do our same ratio again. So 5 SO2. We know what 1 is, and that's 0.05. We're going to multiply that by 5, and you're going to be left with 0.25. So therefore, if you just add them up, 0.25 plus 0.1, you will be left with 0.35. 0.35 moles of gas. So we pop that over here, 0.35, multiply that by 22.4, and you only get 7.84 litres for the volume. Highlight it. Okay, we have part 2 done. Let's move on to part 3. Final part. What mass of solid is produced? Okay, so if we go back over here, the solid is this guy over here, the K2O. Okay, so we're looking for the mass of K2O. So mass equals, so that's K2O, equals number of moles times MR. Okay, so that's not that difficult really. K2O, if you get the MR of K2O, you're going to be dealing with 94. Okay, that's the molecular mass. Let's figure out the number of moles. So K2O is over here, and we're dealing with 2. Okay, it's our ratio there. So 1 is to 2. So I go with my 0.05, because that's my my 1 there. I multiply that by 2. And obviously you're going to get your 0.1 for that. So your mass equals 0.1 times 24, and you're going to get a mass of 9.4 grams. Let me highlight that. Okay guys, so that's that done. It was tricky enough. There was a few different things you had to look for, but really once you got past part I, you're actually okay. And the rest of it is just your formulas and again your ratios. And if you can do those ratios fine, you'll be grand. Okay guys, all the best.